a vegetable crop production and weed science advisor from UC Monterey County. Richard has, for the past 36 years, been working on production issues of leafy vegetables, and his research and extension work has focused on soil fertility and crop nutrition. He has worked on crop nutrition in commercial and organic production settings. So we're really, really thankful to have Richard here today. And Richard, if you would like to take it over from there. Thank you.
Okay. Thank you, Aparna and Margaret, for inviting me. I think this is a fantastic idea that you have, these lunchtime seminars, and, you have a good turnout. So that indicates that you got a good idea going here. And so my background is in mostly in vegetable crops. So that's when I talk about organic soil fertility, that's the perspective that I'll be coming from, is talking about it with regards to mostly from the perspective of vegetables. And then of course, being here in the Salinas Valley, we're mostly a cool season vegetable area. So maybe I'm a little bit narrow in my background, but that's what I got to offer, and so that's what I'll talk about today. And if, like Aparna said, if you have any questions, please. Well, I guess we'll talk about. We have half an hour to talk about questions at the end, so we'll go ahead and do that. So I'll just go ahead and get started. And one of the things, okay, computer. This is something I think everybody already understands, is that, organic soil fertility, there's some things in common with conventional conventional soil fertility, but organic also is in a way is more complex and difficult to understand and to understand as precisely as we would like. And part of the reason is it relies upon, biological processes and recycling of nutrients in the soil microbes to mineralize and make available nutrients that the plants need. And the microbes and different processes that may be occurring, of course, are like nitrogen fixation by lichens. This is kind of, I think, a bedrock idea in organic production, but also other things that might be going on in the soil, such as mycorrhizal associations for a lot of species of vegetables have mycorrhizal associations with fungi in the soil. Of course, then there's decomposition that's occurring, and in decomposition, you're having mineralization of nitrogen to plant available forms from more complex forms of nitrogen. And then there's also scavenging and cycling of nutrients by the crops and cover crops and all that sort of thing. And then also there's a lot of recycling of nutrients that's goes on from the use of compost and manures, and then also other amendments. Some of the organic fertilizers and so forth come from, a lot of times they come from slaughterhouse materials or fish waste and so forth. So what I'm going to do is talk about phosphorus, potassium, the micronutrients, then we'll talk about nitrogen. And phosphorus is one in that in my mind, we really have good soil tests to help us determine the amount of phosphorus that the soil is able to provide for the plants. And one of the things that is true about phosphorus is that the levels do not change rapidly over the course of a season, or even from year to year, they may not change very much. And so the soil tests are a reliable indicator of plant available phosphorus. and so really a yearly test, if you're doing an annual test of your soil, phosphorus can be, you can kind of keep tabs of where you stand just by that yearly test. And there's a little bit of complexity in terms of the sampling, and what tests that you rely upon, but generally, for soils with a pH greater than 6, which is nearly all the soils that we're dealing with here on the Central Coast, unless you're up, in the Santa Cruz Mountains or something like that, where there's a lot of rainfall and you can have more acidic soils and those kinds of situations, or sometimes on some sandy soils. But in general, the overwhelming majority of the soils, agricultural soils, will have a pH greater than 6. So then we use this Olsen bicarbonate extraction, and that gives you the number that you go with. And so, like, if we look at, well, how much phosphorus is enough in the soil, and to answer that question, you kind of have to know which vegetable you're talking about. If you're talking about some of these cool season vegetables like lettuce and celery, they really need quite a bit of phosphorus. So, normally, you won't get a response if the soils are about 60 parts per million bicarbonate or Olsen extractable phosphorus for these two crops. You can probably get away with a little bit less during the summer, but during the winter, when the soils are cold and the roots are growing not as extensively in the soil, then this is kind of a threshold for those particular crops. And then others, cool season vegetables such as broccoli and cauliflower, then the number is actually quite a bit lower. They can get by without with lower levels of phosphorus. And then once you get into the warm season vegetables, their needs are also quite a bit less. So those are just some guidelines. And by the way, everybody who's interested in nutrient management should get a copy of Efficient Nutrient Management in California, Vegetable Production. This is a book, came out a year or two ago now, written by Tim Hartz just before he retired, and he summarized all the current understanding of plant nutrition in this book. And so that's something that you should get it. And this chart will be in that book. And but when we talk about what are some of the sources of phosphorus, if you need to add phosphorus, in a good source, of course, is animal manures and even some composted materials. And what we find is that the phosphorus that's in these manures in particular, they tend to be in this phosphate form. So this phosphate form is the form that the plant takes up. And so the phosphorus that's in manures is just as available as a synthetically available, phosphorus fertilizer. And then, but you will hear discussion of the use of rock phosphate in bone meal. But the problem with these materials is that they're very slowly available in soils with a pH like over 7, and below that they can be more slowly available. So they need to the form of phosphorus that's in these materials is it's like some kind of phosphorus and calcium complex, and it needs to mineralize, and so it's not immediately available. And one of the things we've also seen is that sometimes you can build up high levels of phosphorus in the soil through the use of manures. We've seen really elevated levels, and that wouldn't be a problem. It's not really a toxic element to humans, but what can happen is if you have runoff off of the farm and it gets into lakes and rivers and so forth, that elevated phosphorus can stimulate plant growth and cause eutrophication in those bodies of water. So that's why we actually have been working with growers, conventional growers here in the Salinas Valley, to reduce the amount of phosphorus that they apply to try and make those soil levels less elevated in order to reduce surface water issues. And one thing I'll just show you, this is studies we did a few years ago, and we were looking at the amount of phosphate that was released from 442. And we took this, 442 is a real common organic fertilizer. It's made from bone meal and chicken manure. And what we found was that that really, if you look at the amount of phosphate that was released from this material, it's really quite modest, around 15%, over this period of time that we were measuring. And one of the things that we think the reason for this is that where we were doing this study, the soil had a pH of greater than 7, and that a significant amount of the phosphorus that's in this 442 actually comes from bone meal, and that that it's not that available. And so, even though you got like 4% of phosphorus there, the amount that you actually get is only about 15% of that. So it's not really, under these conditions that we tested it, it's not really being a really good source for phosphorus. Very, very modest source. When we talk about potassium, potassium also is, there's a very excellent test that really helps us understand the need for potassium in the soil. And this is the ammonium acetate extraction, which is the standard test that the labs do. And then what you usually see is that this ranges, from 50 to about 400 parts per million. And typically what you see a very high correlation between higher clay content, you have higher potassium levels. And but it turns out potassium is actually exceedingly important in plant nutrition, because in some of these leafy vegetables, a lot of these plants will take up more potassium than they take up of nitrogen, even in some cases. And so it's taken up in very great quantities. And this is another one where the amount in the soil does not change rapidly over the cropping season. So these annual soil tests that you might be doing give you a good sense of potassium in the soil. And when we look at sources of organic sources, there's the mine, there's potassium sulfate, and there's, and it can have up to 40% potassium. And green sand is actually quite low, and then it also has low solubility. So that is something, if you have an issue, you might need to look at another source. Although people talk about green sand, I hear them talk about it a lot. Wood ashes, in gardens, like in my own garden, we have a wood stove, and I throw the wood ashes out in the garden, but I don't put it on very thick. You just put it on a very thin layer, then work it in. Seaweed can be a source, and then compost can have, depending on the feedstock, can have a significant amount of potassium, and then also manures can have a significant amount of potassium. And then in that same evaluation that I was just showing you, where the phosphorus was only releasing about 15% of the phosphorus that was in the 442. Well, if you look at the potassium, is the exact opposite. Like almost immediately, the phosphorus is immediately available and just comes gushing out of that, out of those prills. And the reason is that it's just not tied up like phosphorus is tied up with calcium and maybe with iron, depending on the pH. And but potassium is just an ion, and it's soluble in water. So it's very readily available if you're using a material like 442. Now, we have seen levels of issues with potassium deficiency here on the Central Coast. This is on a pepper leaf. And one of the problems we've seen is on certain soils, what can happen is the potassium will get what they call fixation. Certain clay minerals will lock it in between. There's two layers of clay, and then the potassium gets in there and gets fixed and is not available to the plants. And so you can have actual potassium deficiency. And And a lot of times potassium deficiency follows a kind of a characteristic look. You'll have this dark speckling that kind of coalesces into necrosis along the edge of the leaf. And this is a very common symptom of potassium deficiency, always on the older leaves. And one of the problems with potassium, and it's also true for phosphorus, is that the roots really need to grow to the nutrient. They're not that mobile in the soil. And so anything in potassium, because so much is being taken up, anything that reduces the ability of the roots to explore the soil can affect potassium nutrition. And for instance, in the early 1990s, when peppers, like up in the Gilroy area, were being transitioned to drip irrigation, all of a sudden we started seeing potassium deficiency showing up. And part of this was due to the fact that they used to use furrow or sprinkler irrigation, which the roots, grew, had a much bigger wetted area that they explored the soil. And then when they started using drip, then the rooting systems were constricted. They were smaller, and then they didn't. They weren't getting the potassium they needed because the roots weren't exploring as much soil. And we've also seen nematode infections on peppers, give you potassium deficiency symptoms. And the reason being is that because the nematodes are inhibiting the rooting density of the plants. And then here's one of these charts again that shows you the amounts of potassium that you'd like to see in the soil in order to avoid having issues with deficiency and so forth in the soil. Now, just very quickly talk about, zinc is another key nutrient, and just a quick word about calcium and magnesium. Normally here in this part of California, we don't really have issues with calcium and levels of calcium magnesium in the soil because we have low rainfall. In general, we don't have a lot of heavy leaching of the soils like you might find in higher rainfall areas. And so we tend to have good levels of calcium. We also might even have calcium carbonate or even some gypsum in the soil. And so we don't really run into deficiency of these nutrients, but you will see localized issues with calcium availability, like in tip burn or blossom end rot. And these are kind of more physiological issues rather than soil availability issues. So that's about all I'll say about those, unless somebody has specific questions at the end. But the one thing I will say is that compost and manures generally supply a lot of these other nutrients. Like if you look at even yard waste, which is yard waste compost, which is kind of, I think, kind of our a poor quality compost. It's made out of plants, and so it has all the nutrients that plants need. And so so like zinc and boron and even iron, these things you will get if you're using compost regularly. And again, here's some levels of these various nutrients in the soil, and kind of gives you the thresholds for where you would like to be in the soil. Now, the problem with boron is that you definitely want to be over a part per million, but you don't want to be over like 2 or 3 parts per million. It's got a very narrow range where it's safe in the soil, because you can have excess boron in the soil. And there's some spots in San Benito County that have high boron in the soil. But I just did this little calculation. I just looked at some compost analyses and then calculated how much, like zinc and some of these other nutrients you might get from just adding 3 tons of compost, which is a pretty common amount that people apply. And you can see you can get a fair bit. So compost and may take care of the needs for some of these micronutrients that we would have here. And so now I'll just spend the rest of the time just talking about nitrogen. And one of the things we have to keep in mind about nitrogen is that, unlike, what I was saying about phosphorus and potassium, I just look at your yearly soil analysis and you can figure out where you're at. Nitrogen is not like that because it has different forms that it occurs in. And so like in soil organic matter or even in crop residue, the nitrogen is, generally in some kind of more complex form that's not immediately available to the plant. And so what we rely upon is mineralization of those more complex forms of nitrogen to the plant available forms of nitrogen, such as nitrate and ammonium. And so this mineralization of nitrogen, it depends on the C to N ratio of the parent material, including soil organic matter. The C to N ratio is very important because if there's too much carbon, then the microbes want to absorb that carbon, use that carbon for their growth, but they also need nitrogen to balance that. And so then they get the nitrogen before the plant does. So it affects availability to the plant. Of course, temperature. And then the third is the placement of the material. Where are you putting this? If you're using fertilizer, are you just dropping it on the top of the soil or are you injecting it into the soil? So these make a difference in how much is available. And then one of the things that adds further complication to this whole story is that nitrate is highly mobile in the soil with irrigation, water, or rainwater. And in what can happen then is that it gets leached too deep beyond the root, the depth of rooting of the crop that you're growing, and then it's not available. And so these are some of the dynamics. And one of the things I think is that really, if you look at nitrogen, it's really highly complicated and it's expensive to supply to crops. And as I mentioned, it starts off in these very complex, highly complex molecules, and then it has through the action of microbes, they decompose or break it down and mineralize it then from ammonium and then to nitrate. And those are the forms that generally the plants mostly are absorbing. And so if we go, well, how much nitrogen do we need to apply? Well, again, in this book that that I mentioned to you earlier by Tim Hartz, he has a nice chart in there, and it shows, this is some studies we've done over the years looking at how much nitrogen do these crops take up. And so this is not a recommendation for how much nitrogen to apply, but it gives you a starting point. It gives you a sense of what are these crops taking up. And then it's possible, that's like a starting point to try and understand how much nitrogen do I need to be applying to these crops. And you can see some of these crops are taking up huge amounts of nitrogen, like crop like Brussels sprouts or even broccoli and bell peppers and so forth. And so they're taking up a lot. And the question is, do we need to apply all that as fertilizer? Or are there other sources of nitrogen that the plant takes advantage of? And so we'll talk about that now. And here's a real nice chart that Daniel Geisler and Patricia Lazicki Davis put this together. And what they're showing here, this is the level of mineralization of nitrogen from soil organic matter. Here's a soil organic matter that's 2% organic matter in the soil. And then this line here, this is the soil that's a 1.4% organic matter in the soil. And you can see a soil with a higher organic matter. And this is in the Salinas area over the course of the year, and it peaks out in the summer. At its peak, it's releasing about 0.8 pound of nitrogen per acre per day. And but a lower organic matter soil like this one here is at its peak is releasing about 0.5 pound of nitrogen per acre per day. Okay, well we'll try and make sense of what that means in terms of a plant growth. And what it means is that if you take a crop like spinach, that's growing and taking up probably 5 or 6 pounds of nitrogen per acre per day, you can see that the soil organic matter alone for those crops is not enough. Now, what about if you're following a crop of lettuce or broccoli, celery? What about if you're early in the season, you're following a cover crop, and these different crop residues contain different amounts of nitrogen. So something like spinach might have 20 to 40 pounds, lettuce 60 to 80 pounds of nitrogen. That's like in this picture, it's getting dissed in. That's because they strip off the leaves, and then there's nitrogen left in the roots and so forth. Something like broccoli and cauliflower, they might leave behind 160 to over 200 pounds of nitrogen in this residue, because you're taking such a small part of the plant away in the harvested product. And then cover crops, depending on what the cover crop is, it can contain quite a range of different amounts of nitrogen. But this nitrogen, then, it's in a crop residue, and then what percent of what's in that residue, this number that I just mentioned to you, how much that's in this residue then becomes available? Well, it depends on the percent nitrogen, and this also relates to the carbon nitrogen ratio. But like something like, let's say you had a cover crop that had 2.5% nitrogen, you might get 40% of that nitrogen. And this is the reality of these residues, is they don't break down entirely. They have kind of an initial rapid breakdown over 2 to 4 weeks, and then it slows down. And so something that's like 3% nitrogen, you might get 60% of this amount of nitrogen that's made available to in the form of nitrate, and which then a subsequent crop can use. Another source of nitrogen is nitrogen from irrigation water. And so depending on how much nitrate is in the irrigation water, you might have actually a pretty significant source of nitrogen that's available to the plant. And I know some growers probably listening in right now, they have some wells that might have 40 parts per million. You multiply it by this multiplication factor, and it tells you how much pounds of nitrogen per acre inch of water do you get. In this case, you get about 9 pounds. And if you're applying 10 pounds of water, 10 inches of water, and you multiply 10 inches of water times this 9 pounds per acre inch, you can see that it can supply a pretty significant amount of nitrogen to the crop. Now, okay, so those are all other sources. We know those crops. Let's keep that broccoli idea in mind. If they need over 200 pounds of nitrogen, and they're getting, a very limited amount from the soil organic matter, maybe getting some from the water, and whatever the prior crop was, they might be getting some. Then you have to make up the need with the use of applying fertilizers. And so here's just some of the common fertilizers, like here's one real common, feather and blood meal. It's 12% nitrogen. Meat and bone meal is 8% nitrogen. It's got some phosphorus and potassium. And one of the things that we think about, and you're going to start seeing this on the organic fertilizers, they're going to start listing the carbon that's in that fertilizer, because we need to know that carbon nitrogen ratio, because that is in a really elegant study that Daniel Geisler and Patricia Lazicki did. They showed of these different fertilizers how much becomes available to the crop. And they did a 12-week incubation. And what they showed, for instance, let's look at these green ones here. So here's your granular fertilizers, so like the 442, you might be getting about 50% of it. But it's all based on this carbon nitrogen ratio. And that's why I think it's really nice that the fertilizer companies are going to start putting the carbon amount on there so you can see what the carbon nitrogen ratio is, and then you can relate it to this chart, and then it tells you how much it's becoming available. And then some of the fertilizer companies also will, salespeople will also provide some estimates of how much becomes available. There, I saw a chart recently where they're doing that. And then here's kind of what it looks like, is that, again, see how you get this rapid release and then it flattens out. And then none of them release 100%, but depending on what that carbon nitrogen ratio or the nitrogen content is, they release a certain amount. So like here's a 4% materials releasing about 50%, blood and feather meal maybe 70, and guano is releasing a higher amount. But if you look at guano, it already starts off with a high amount of nitrogen in that it contains that's already available, is available nitrogen, ammonium or nitrate. So that's the difference. You know, if it didn't have that, it would be, you know, it'd be down here. But you know, this is why people like to use guano for fertilizer. It's a good organic fertilizer. And then this graph just shows you, you know, the amount that you get from these different materials. And then you can see here's like poultry manure, you know, it's releasing about 40 to 50%. And here's the guano again up at 70. And yard waste compost is releasing a very small amount, less than 10%. And something like feather meals around 60 and so forth. You can see these estimates and that. And then one final detail about using these fertilizers is, where do you put them? If you incorporate them, and this is a study we did, we put the fertilizer in these pouches, and then we would pull the pouches out every week and then weigh and analyze the nitrogen. And we were able to do an estimate of if it's buried, you know, incorporated into the soil, you get a higher percent, and this is the 442 that's released, than if you leave it on the soil surface. And part of that is because with sprinkler irrigation, you get drying between the irrigations, and so all the biological processes stop. Whereas if it's buried in the surface, in the soil, it's the biological processes continue, and you get more of the material, more of the nitrogen becomes available to your crops. And just a comment about compost. We already kind of talked about, you know, composted yard trimmings. Actually, this goes back to this graph. This down here is the yard trimmings, and you can see that how much is released. It's less than 10% in this example, and that same thing is shown here. That because it's low nitrogen, the carbon nitrogen ratio is quite high. It's over, you know, can be over 20. It's just not releasing much nitrogen. And so it actually, you know, people talk about, well, I'm going to put compost on to fertilize my crops. Well, if you're using yard trimming compost, probably not getting a lot of nitrogen available, and its release rate is measured in years rather than in weeks. Whereas, you know, a composted poultry manure starting at a higher nitrogen content, its release is much quicker in weeks and months. It's still, you know, in this example, it's around in the high 30s. So, and then just one other detail about these organic fertilizers is how much do they cost? And so in this area, we use a lot of 442, and part of the reason is it's in terms of the cost per pound of nitrogen, it's about $3.80. And these are some numbers I just got from a fertilizer company last week, so they're pretty current. And these are costs for delivered product. And so, you know, you can see, and then the meat meal is also about $4 per pound of nitrogen. And then some of these materials like this soybean hydrolysate, which is something you can mix with water, and it solubilizes very nicely, and it won't plug your irrigation system. It's quite expensive because it's a kind of more of a high-tech organic fertilizer, but it is organic. And then the liquids that can be quite expensive too. And this is in terms of costs per pound of nitrogen. So if, let's say you decide you want to put on 50 pounds of nitrogen, see, this is how much it'll cost. Multiply 50 times that. And the crops that, like I mentioned, you know, spinach is taking up, you know, we were talking about this pounds of nitrogen per acre per day. You know, a crop like spinach in the final 2 weeks of its growth cycle is taking up, you know, 5 or 6 pounds. And but the soil is only providing a very small amount. And so then you can see that really on a crop like spinach, you know, you're probably going to be putting on a lot more fertilizer. Now, something like broccoli, it takes up a smaller amount, and plus it's out there for a longer period of time. And what we've seen with broccoli is that it's actually pretty good at scavenging nitrogen from the soil. And the reason is because its roots go deeper. They'll go down to 3 feet and beyond. And so, so when you see, remember those big numbers that are like 300 pounds of nitrogen that the broccoli contains, you don't really have to put that all on, because in general, it's also doing quite a bit of scavenging. So just in summary, you know, organic soil fertility is more complex than conventional. And I think, you as growers, one of the things that's really important is your observational skills and seeing how plants are responding to these materials, because it's really hard to precisely say sometimes how much to put on. You know, I didn't talk about soil testing, but, you know, that's something that we could talk about. But in general, I think growers have learned, you know, how much that the crop needs, but that's affected by how much rainfall, the soil type, and the time of year, and so forth. And one of the things I've always find very interesting is that on a crop like broccoli, people have learned they don't need to put on all that the crop takes up in terms of fertilizer. They've, you know, through watching their crops and seeing how they respond, in general, they generally tend to put on less than the crop takes up. Whereas that's not so much true for a crop like spinach, because of that intense short growing season and intense uptake period. And so, but this all comes from, I think, really good observational skills that you as growers develop over the years, watching your crops. And I, you know, I encourage you to take careful notes and kind of think about some of these concepts we just talked about, and they kind of help you make sense of what you see out there in your field. So Parna, I'll stop there.